You're a test engineer tasked with developing an automated functional test system for a new product, but time is tight to get the system into production. You need to make 4-wire resistance measurements between sequential DUT pins before powering up the DUT and making voltage measurements on some of the pins. After researching options, you select a Pickering PXI 132x4 reed relay matrix and house this in our 2-slot LXI modular chassis. You're using existing LabVIEW routines for the DMM programming, but have never programmed a Pickering switch before and are unfamiliar with our software drivers. What's the quickest and most intuitive way to get the system up and running? Happily, SPM makes programming the matrix a piece of cake in just 4 simple steps. Step 1. List all available switch modules. SPM will automatically discover any Pickering switch modules connected to the controller and display their available external connections. Step 2. Define the module interconnections. This is only for switching systems that use multiple interconnected switch modules and is not required for this simple matrix example. Step 3. Define the required test system endpoints that would need to be connected via the switching system, e.g. DMM high, PSU+, TP1, etc. And step 4. Start simply connecting and disconnecting the required endpoints in your API of choice. SPM will automatically handle all of the necessary relay operations to implement these connections. C, .NET, Python, LabWindows CVI and LabVIEW are all supported. No knowledge of the matrix operation or Pickering software drivers is required. So let's look at the tool in operation. Assume your controller PC's LAN is connected to the LXI chassis and SPM and our standard LXI driver package have been loaded. Firstly, launch SPM and create a new project. Then auto-detect the matrix module and its connection information is automatically loaded. Rename it and assign intuitive endpoint names for all the DMM and DUT connections to the matrix. Numerical pin names can be automatically incremented for consecutive endpoint names. Now launch the interactive SPM soft-front panel and start connecting endpoints together for the first 4-wire resistance test configuration. Run the test and check the correct relays are energized on the matrix soft-front panel running in monitor mode. Assign this list of endpoint connections to a connection sequence for ease of implementation. Change endpoints to reflect the second test configuration. Run the list and check the correct relay operation on the matrix soft-front panel as before. Create a second connection sequence. Repeat for all additional test configurations. Run all connection sequences consecutively, remembering to disconnect all connections between each and include any necessary delays. Add the PSU endpoints to SPM. Connect to the matrix without disconnecting DMM measurement group. SPM's automatic short-circuit detection algorithm prevents this connection, as it would cause a short to an already established connection group. Disconnect the measurement group and accidentally connect PS plus to PS minus. This is allowed as there has been no endpoint connection added to SPM yet, and it will result in the matrix relay short-circuiting the PSU and inevitable damage. To protect against this, declare PS plus and PS minus in separate endpoint protection groups and reconnect them. SPM will now flag an error, safeguarding the switch module. These two protection mechanisms are a critical feature of SPM, ensuring correct measurements and protecting the hardware from potential damage. Connect the power supply to DMM to verify the output voltage, and then connect to the relevant DUT pins via the matrix. SPM will handle any Pickering switching system, from a simple matrix to this example with 5 interconnected PXI switch modules. The concept is the same for all, namely switching in 4 simple steps. Thank you for watching. To find out more, please visit pickeringtest.com/SPM.